Today is lesson 3. Let's start by review what we learned in lesson 1 and 2. First, we know that Python is a general purpose programming language. General in the sense that anything that can be computed by using Python programming language. Python programming language is named after Monty Python, which is the UK comedy show. So, fun is part of the DNA of the language. Python is relatively easy to learn because it is an interpreted language. Interpreted in the sense that Python program will be run by a software, one instruction at a time, rather than run by the computer hardware, the CPU, Central Processing Unit. So, interpret language is different from compile language, such as C, Java, C#. In those languages, programs are compiled into machine code first. The machine codes are not human readable in general, unless you know the machine code well. And this machine code will be executed by the machine CPU directly. In Practical 1, we learn how to install Python's IDLE, which stands for Integrated Development and Learning Environment. So Python's software can be installed following the instruction in Practical 1. Once it is installed, you should be able to find the IDLE easily. When you first start IDLE, it will be executed in a shell mode. In the shell mode, the Python interpreter behaves like a big calculator. Like a calculator, it waits for the user to enter a single instruction or a single expression. Then the interpreter execute the instruction or evaluate the expression and print the result of the evaluation. After that, it loop again. So here is example of using Python shell. In other words, using Python interpreter in shell mode. So you enter a equal to 2, which is instruction. Python execute it immediately and store 2 in a variable called a. Then next, you issue another expression, a times a. Then Python internally evaluate a times a, which is 4, and then print the result. And then it loop again. Shell mode is convenient for learning and testing short code. The user get immediate feedback, so you can learn and experiment different instruction. However, it is not the right way to execute large program. For execution of large program and for development purpose, the interpreter need to run in program mode. In program mode, the programmer write source codes in a text file. Then we activate the interpreter. Ask the interpreter to load all the code into the memory and execute it together. You can write Python program using any text editor such as Notepad. However, it will be easier to write Python program using IDLE because IDLE understand Python syntax and can show you the structure of your program using different color. From IDLE shell, you can click the file menu and choose new file. A new file will start, and inside the new file you can enter Python code such as a equal to 2, b equal to 3, and print a plus b. To execute this code in the file, you click Run in the menu and choose Run Module. The runtime system will ask the user to save the file first. So you save a file and give it a file name, and typically we save the file with the extension py, which stands for Python. After you save the file, the runtime system will execute the code and produce the output in the shell. So the shell is the control center. In lesson 1, we also introduce positional number system. Consider an n-digit number in a system that base k. And n-digit mean what? You got A0, A1, A2, AN minus 2, AN minus 1, where A0 is the least significant bit and AN minus 1 is the most significant digit. For this n-digit number, the value will be an minus 1 times k to the power n minus 1 plus an minus 2 times k to the power n minus 2, and so on and so forth. For example, if k is 8, that means it's an octa system. Then we got number 2, 3, 4, 5. 2, 3, 4, 5, the 2 is in the position where the value is 8 to the power 3. So 2 times 8 to the power 3. The 3 is in the position with value 8 to the power 2. So this 3 represents 3 times 8 to the power 2, and so on and so forth. There are many position number systems. For human being, we like to use decimal, which is base 10. So we use the digit 0, 1, 2, 3 up to 9. However, for computer, internally it uses binary. In other words, the number is in position number system base 2, and it got only 2 digits, 0 and 1. For convenience sake, sometimes we will represent a number in base 8. We call it octa system. Octa means base 8, so the digit 0, 1, 2, 3 up to 7. Another commonly used number system is base 16. It's called hexa system. The digits are 0, 1, 2, 3 up to 9, then followed by A represent 10, B, C, D, E, F represent 11 up to 15, from 0 up to 15. In lesson 1, we also practice practical 2, in which we experiment with many Python operators, including arithmetic operators, such as addition, subtraction, mod operator, and so on and so forth. Comparison operator, to compare two numbers, whether they are the same, which one is greater, less than, and so on and so forth. Bitwise operation, compare two bits using AND, OR, and complement operator. Logical operator means logical AND, or negation operator. Membership operator means whether a number objects belong to a set or not. Then we study identity operator. Two objects can have the same content but different identity. In lesson 2, we study program design. We introduce two powerful program design tools, pseudocode and flowchart. So we use a easy game called Guess Game as a case study to introduce the pseudocode programming design. So in this game, the program first initialize lower bound, upper bound to 1 and 100, and it will generate a magic number and store the magic number in a variable called magic. Then the control of the program go into a loop. It prompts the user for input and hint the user the input range. It waits for the user to enter the guess and store the user's input into a variable called guess. After that, the program make decision using nested if statement to decide whether the guess is greater than the magic number or the guess is less than the magic number. In this case, the system will adjust the upper bound and the lower bound, in other words, adjust the range accordingly. If the user get the magic number correctly, the system will display bingo, congratulations, and so on. After that, it get out of the internal loop. After that, it asks the user whether they want to play the game again. If the user indicate no, then the system will end. Otherwise, the system will go back to the beginning of the program and the user will play the game again. Another powerful program design tool is flowchart. In flowchart, we start from the initial node to the ending node. So here, the program start from this action node and initialize some variable, lower bound, upper bound, and magic number. After that, the flow go to here, another action, which prompt the user for the input range, for example, from 1 to 100, and gets the user input. Once you get the user input, the flow will go to this diamond. This diamond here indicate a decision. In this case, the decision has 3 outcomes. Guess greater than the magic, guess less than the magic, or guess equal to the magic. In these two cases, where guess does not match the magic, the system will adjust the upper bound and lower bound and go back to loop again. So the loop get a user input, make the decision, adjust the bound, repeat again. Get the input, make decision, adjust the bound, repeat again, until the user get the magic number correctly. In that case, the system display bingo, congratulations, and get out of this loop. Then the system asks user whether to continue or not. If the user say no, don't want to continue, it will exit and the end of the program. Otherwise, if the user say yes, you want to play again, the control will go to beginning and reinitialize the lower bound, upper bound, and generate another magic number, and the game repeat again. In Practical 3, you are asked to complete the first version of the guess game based on this skeleton code. Well, we haven't formally studied the programming language yet, but since Python is so easy, so you should not have difficulty understanding the code in general. well, not in detail maybe, but roughly understand the code structure. All you need to do is write this part where guess greater than magic. This pump sign here mean command, means I ask Python ignore this part, but you are going to replace this command with actual code. The code should be similar to the case where the guess is less than the magic number. This is the end of revision for lesson 1 and 2. Thank you for your participation.